First of all, I'd like to start off by saying that I wanted to recommend the link that Pat put in the chat, not chat, the mailing list. And so, hey Pat, if you've got that link, can you go ahead and put it in the chat for other people? The video on how to do deep learning databases, the mistakes. It's essentially about a 15-minute video. Okay, I'm sorry for that, Ben.
Did that happen last week as well?
I don't know. Did it? Did anybody else see that?
No, that's 2 weeks in a row. Are we doing something to advertise ourselves inappropriately?
No, I don't think so.
Was that spam?
I have no idea. It's a good question.
I don't know who it was.
Yeah, since I'm new at this role of leading, I'm afraid I was a little slow in kicking them off, but I finally figured it. Okay, so anyway, so Pat, if you could post that link, that would be really good. It was an excellent video. If you're on the mailing list, you can get it there. It was from OpenCV, and it's the gentleman who wears the little, I don't know what you call those hats, golfing cap or whatever, and he goes over in great detail on the mistakes that you can make while building a data set. And that was really cool. And he also shows how to notate the images, and they've come a long way from when I first started. When I first started, you had to have all the pictures the same size, and you can only, you could, when you identified an object or notated an object, you formed a box over it, and it was tied to the image's pixels. But now they normalize that, and it's much better procedure. Okay.
Doug, are we recording?
Yes, we are. I might have to adjust some of it.
I posted that link in the chat.
Yeah, he also has a follow-up one where he talks about some other really nice feature about that, but I would definitely start looking at that guy's channel if you haven't already, because he's got some really practical information. I'm sorry? Who was it? Was that David? No. Okay. So,
I think that was me.
okay.
I started up that video. I looked at it first.
Okay, that's fine. If you go on mute, you can do that. So, did you see that? Did you watch that video, Kareem? What's going on, Kareem? Guess he didn't. Anyway, anybody got anything to show? Who wants to be first in line? It'll be a short meeting if nobody wants to go. Okay, Ted. Let's see.
All right. So I have a follow-up on my question a few weeks ago about the wheel encoders. I was having trouble with them. Well, so it turned out part of my problem was I'm using the RoboClaw motor controller, and there's two settings for it to report: instantaneous velocity and
Does anybody know this guy?
Average velocity. And I was accidentally. I had one wheel on the instantaneous and one on the average. So the instantaneous was giving me a lot of jitters up and down because it's instantaneous. And so it was confusing me why one wheel was jittery and the other wasn't. Mm-hmm. So I eventually solved that problem. And then I think my other problem was with the I was controlling the motor controller with a serial connection from the microcontroller, and I think one of the wires was a little bit loose or something. Anyways, I replaced the wires, and that seemed to fix it, because it would suddenly jump up in speed or fall way down in speed, and I think it was just a communications issue with that.
Okay. All right. Well, that's good. So is it working now?
Yeah, so it's working a lot better. Of course, then I went and decided I wanted to try putting some Kalman filtering code in there, and so I tore the code all apart. And I'm still trying to get the Kalman filtering to work at all. So right now it's not working. So no gold star for me.
You did use
Ted,
Git.
for the,
You used Git, didn't you? You didn't take your working stuff and start changing it, did you? You used Git, right?
No, yeah, I just took the files. I didn't do any commits. I do have it in Git somewhere, but I didn't bother to commit it. I probably should have.
Yeah.
Ted, when you say that the robocall can give you the instantaneous or the average, what is the time window for the average?
You know, I'm not sure off the bat. It said something about the instantaneous was every 300th of a second, but I don't know what algorithm they're using for averaging.
Well, averaging typically happens over some sliding time window.
Yeah.
Right.
So it's useful to know how big that time window is to know sort of what the delay is.
Yeah.
I make those two values available in software on my systems, and different ones are usable for different things. Useful. Sometimes it's really useful to know the actual instantaneous.
Yeah,
velocity,
because
sometimes you just run it.
if you look at the math, if you have a moving average, okay, that's where you add a new one on the front end and you drop an old one on the end. Your time delay, you're running 1/2 of the number of samples behind. Otherwise, that's the delay, half the number of samples you're taking. So, like if you're taking a whole second, then you're actually reading from half a second back. I mean, that's the value you got. So you, like David said, you have to be careful about the delay.
Yeah. And one thing I've done in the past is used, I think it's called maybe an alpha beta filter, where you multiply each new value by a constant, and you multiply the old values by another constant that both add up to 1.
So you get a response like that rather than like that.
Yeah.
Yeah, that's good technique. That's usually in that depends on, well, no, I was going to say it depends on how noisy your number is too.
Mm-hmm.
Okay.
Well, Doug, I also had just a comment or a query I wanted to throw out to the group, but it also
Okay.
deals with the encoders. So can I jump in here?
Sure.
Okay, I have to stop eating. Here, I don't have any nice graphs or anything. I'm just going to wave my hands. But here's what I discovered. This started with the thought that when I run calibration routines on the robot, or even when I run them, just put it down and run some pattern and see how close I can make it back to the origin. The suggestion was made years ago, well, you should run slow because the robot will be more accurate when it runs slowly. And that's what I've always done. So I calibrated like 20% full speed or something like that. But I started wondering, is that really true? I think the argument made is that the robot slides more when it's going fast, and so your locations would be less accurate. So I decided to test to see if that was really true. So if it is true, then what you should see is if you run the robot at, say, 20 and then run it again at 40, if you're going twice as fast, the error should go up. But my thinking, as I thought through this problem, I thought, okay, look, I actually sample the encoders at a regular rate. That is, on this robot at 25 hertz. So the speed you're going is how many clicks you got in that 25 hertz. But when you run twice as fast, that means you run the course in half as much time. So there's half as many of those samples, which is where the error is collecting in the integrations.
Oh, okay.
So I also argued, well, if I run faster, the error should go down. So then I ran the tests, and to cut straight to the chase, the error remained the same. Not at all what I was expecting. So as I thought it through, I thought, okay, it looks like that the error is not tied to the actual amount of time it takes to run, but rather to the total number of encoder ticks collected.
That's probably
That
true.
is
Yeah.
to the distance traveled, basically. Whether you drive that fast or slow didn't seem to make any difference.
Well,
Does that- okay, that's all I have to say about that. But
I think you might have missed another error source. The faster the wheels go, the more they tend to expand, especially if they're flexy wheels. So
I don't think these are being slung out by centrifugal force.
you're not going that fast.
I'm not going that fast. No, I'm going like, moderately slow and really slow. It's
Yeah.
in that range.
But you do feel, David, that
The
if you
lane
went
speed records
fast,
then, huh?
if you went fast, that the original assumption would be true. That you would be more accurate because you would slip more.
Well, that was one hypothesis, but I haven't been able to prove that true.
Yeah, but I'm saying is
So,
if you,
It's acceleration related, probably,
yeah,
whether you actually slip.
yeah, that's true.
Okay, I think that with the acceleration curves that I use, or the ramps that I use, that the wheels don't slip no matter how fast I'm going. They might slip in turns though, if the robot's sliding sideways when it's going really fast, which would also affect the accuracy of the end location. But as I say, at this point, what I wasn't expecting at all was that they would be exactly the same.
Mhm.
And so,
Well,
Are you-
I've never seen your robots go particularly fast. So have they always been clamped at what, like 40% or something, or?
yeah, when I run in competition or something like that, I'm usually running about 40%. One time when we did the quick trip, I ran at 80%, but it still came back and hit the target accurately. But generally, that's pretty fast to run around indoors. That's about 2 meters a second or something like that. When you hit things, you hit them real hard.
Is this just odometry, or are you using other, like gyros?
No, this is just the straight odometer.
Okay.
No help.
I was gonna say, when I run gyros, the gyros drift over time, so the faster I can get around, the more accurate they are for heading.
Well, and that's kind of what I expected here. I thought it would be related to time, so the quicker trip would show fewer errors or smaller errors, but it didn't. So it seems like at this point, the errors are related to, it's like there's an error rate per encoder tick, and that error is kind of constant no matter how quickly or how slowly you collect those encoder ticks. And
You
not,
should try running on sand.
well, you have fancy, expensive GPS stuff when you do that, right?
That's true, yep. And it still gets stuck.
Okay, I think Michael had his hand up, Doug.
Okay, Mike, go for it. Michael.
Well, I guess y'all know, I think I've told you this before, this is a metal shed you get at Home Depot. It's my new man cave. With installation. I got kicked out of the house. My granddaughter kicked me out because she needed a bedroom. So anyway, so my whole man cave was an old bedroom. Anyway, so I built it. My next project, now, do you get a star or something if you get running? Is that right? Oh,
Yeah, if you get something, if you get it running.
I'm fixing to mount this in the walls, my new air conditioner. I get this running, does that count?
That might be,
Does that have wheels?
yeah.
We've had long arguments as to whether or not air conditioning systems are robots.
I was just gonna, yeah. fixing to put air conditioner in this thing. So, I got another thing. I'm fixing to learn, which I've never done before. I messed around with Arduino, being in the club and all, but
Yeah.
I'm fixing to learn Arduino, Python / Arduino. So I'm fixing to learn some Python to just for the heck of it, I guess.
Yeah.
That's about all I got. I'm learning from a guy. Y'all ever heard of a guy named Paul McWhorter on YouTube?
No?
Paul McWhorter. He's an old engineer, electronics engineer, and he does this stuff for free. Does some really cool classes on YouTube. So I'm fixing to take them. So that's all I got to tell you.
Okay.
Fixing to learn some Python.
Hey, well, Mike, before you leave, I see all those boxes. Can you kind of tell us?
Go back there?
Yeah, can you kind of like walk through your man cave and say how you're going to build it out for a few minutes?
Boxes, that's just one box. All the rest of that back there is insulation.
Oh, I got you. Okay. It looked like a wall
See,
of boxes.
I know it looks like a bunch of boxes. That's just insulation. Over here, let's see if I can. See, there's the build table that I can move around.
Mm-hmm.
There's a 3D printer. There's another 3D printer. I made this table. This table that the computer's sitting on
Yeah.
is made off of sawhorses and some really heavy duty stuff.
Cool.
Big old table here, and then here's a bunch of my tools and stuff.
Okay.
That's about it. I'm gonna build y'all seen that claw machine I built? I'm gonna build another one, the robot arm
Yep.
claw machine for the Halloween carnival thing. It'll be built on this table. And I can move these tables around and double them up and stuff, whatever I need to do. That's about it. That's all I need to do this kind of stuff.
Yep. Okay. Well, that's cool.
Michael, is it raining where you are?
Yeah, it's starting to.
And what does it sound like in that metal
It
shed?
ain't raining yet. I don't know what it sounds like with the insulation on it, but we're fixing to find out. So, it's just one of those metal buildings, one of them Arrow $700. Let's see, it's 10 by 14. So, and anyway, that's about what I got. And it's big enough to build, do this robot stuff in.
Yeah.
So,
Yeah. I'm kind
Well,
of
as memory
envious.
as memory serves, you did get a gold star when you first put it together.
yes, I did. Absolutely.
Well, and I
But this
realized that if your
Go
AC
anyway.
unit has a PID loop in it, it might qualify.
It probably does. It's probably got a little electronic controller in there. It does.
Yeah.
Does it have a motion detector to detect presence to turn on?
It's got a remote. It has a remote with it. So
Somebody's
got
got
a
his hand up.
sensor in it.
Might ask a question.
Somebody said something about it. Okay.
Yeah, can you guys hear me?
Yeah.
Yeah.
Oh, yeah.
So I'm curious. I am new to this club, and you guys are obviously the experts when it comes to robotics. How does one get started on this?
What are Ben? What are your strengths? Do you like to program? Do you like to build things?
So I want to try new activities, and hence why I'm in this club. It's to answer your question. I do have a programming background,
Okay.
but that doesn't mean necessarily what I would want to do per se.
Okay. Well, then I'm going to jump up as a beginner, and I'm sure other guys can add to this. Robots are hard, and the reason they're hard is because you have to have the programming, you have to have skills in programming, you also have to have mechanical skills. You have to build your base and whatever, and a lot of people with programming skills really don't like to build stuff per se, from scratch. So what they would prefer to do is buy a kit, and a good starting kit, we can probably give you some ideas on that. But you might you know, like you noticed that Michael had 2 3D printers, and some of us have mills, and some of us have other tools, and some of us don't. So depending on what your, you know, if you're living in an apartment, you're not going to have a workshop, most likely. You might belong to a maker space, which would give you a lot of tools, but maybe not. So if you're in an apartment, you probably would, you know, you probably want to get a soldering station and a few things like that, but you might not want to have anything that's hardcore, you know, like drill presses or anything like that. And so in those cases, you know, buying a kit, a chassis is a smart way to go. And then the other, so one thing is what you can do comfortably, and then the other thing is, you know, how much you can afford. Like any hobby, you know, this could become quite expensive, but it can also be done very cheaply. You know, it just depends. So I don't know. So can you kind of give us a little talk with that framework? You know, like how much money are you like? You know, a young person with lots of money, or are you?
Yeah, I'm a.
Or
Sorry,
you,
go on.
or are you in school, or you know what?
You know, I'm a young person. I guess with decent amounts of money. I mean, I'm an engineer by profession, so
Okay.
we get paid quite a bit of money.
Mm-hmm.
But I just graduated, so I just started my job.
Yeah. Okay. Well, that's
What kind of job, Benjamin?
I am currently in I'm currently on the cybersecurity team.
Aren't we all?
yeah.
But no, I do love physics. Okay, I like physics and math. So I would like to do more math in general.
Okay.
Or science in general than I currently do at my job. So.
Well, I would kind of second what Doug said. There's kind of a big steep curve to get up over just to get something that, you know, you can turn on and put it on the floor and it moves. We sort of jokingly, we have what we call a gold star, which is that anybody who actually can do that, they get a gold star. And that's a recognition of how hard it is. So anything that can ease into that, and in particular what Doug was suggesting, there's a lot of beginner robot kits out there. They're not very expensive. They generally often come with a simple microprocessor, an Arduino or something like that, that can get your foot in the door. And then if you decide, well, the limitations of this physically, I want something. Yeah, there you go. What Ray's holding up. Ray, take it.
Hello?
Ray, your
I
mic.
must
There you go.
have missed that 'cause I didn't see that at all.
Oh, it's a Romy by Polulu. Polulu is a company out of I think they're out of Las Vegas,
Yes.
and they make a couple of different small kits like this. But SparkFun also makes kits. Vex. You could even look at Rev Robotics, REV Robotics. You know, they sell kits. So there's several different companies. I would, guys, correct me if you disagree, but get something where the motors have encoders on them, and you can do some, you know, some more advanced things versus a platform that doesn't have it. You're kind of limited there. This one can actually be controlled by a Raspberry Pi. There's a Raspberry Pi connector, so you can do some fairly sophisticated things with it.
Ray, don't assume he knows what that means.
SmartFun.
Raspberry Pi.
SmartFun, Vex, RAV Robotics. You said.
Yeah.
Something with motors.
Yeah,
something
SparkFun is
with
one
motors on
company. Rev Robotics is another.
Ray, could you
Okay.
could somebody put those in the chat? Put links for him in the chat.
Sure.
I got something I might want to show him that might help. I've got this, these starter kits. You can get them on the internet. You know, they're just Arduino starter kits that get all kinds of stuff. Well, they come with all kinds of things, and are pretty reasonably priced. And they'll get you learning how to run an Arduino. I don't know how much you know about an Arduino, but these
I know they're a
Go ahead.
microcontroller. I know they're different from Raspberry Pi, which is a microprocessor. I know it's run by, I guess it's no operating system on this here. The code is pretty much running on the
Bare metal.
stuff.
Yeah, but it's there's an environment that's why a lot of people like to start with Arduino, because there's an I don't know, what would you call it?
Support environment.
Yeah, support environment. So like a lot of the more tricky things to do on a microprocessor have already been done for you, and you have a very simple piece of code that you can do to implement it. I'm trying to think what it AP.
IDE.
There's a 3-letter.
An IDE.
Anyway,
FBI.
API.
but anyway, what I'm saying is, do you have any experience with microcontrollers at all?
No, I do not.
Okay. Do you have any knowledge about Linux machines?
I have lots of knowledge about Linux machines, yes.
Okay, so your tendency will be to go to a Raspberry Pi. Okay, but most robots have a second controller, like an Arduino. It doesn't have to be an Arduino, which is a microprocessor to do the stuff that has to be done real time. And so what Mike was suggesting was, yeah, there's another one that's an ARM. That's a very good one. So if you have never dealt with any microprocessors, then I would definitely say that you should go ahead and either get a kit like Michael, or if that's too expensive, go ahead and just buy piece by piece, because that works too, because the one that Michael's got is more of a training kit, where, yeah, there's another one. There's lots of microprocessors that we could recommend. The absolute simplest will be the Arduino.
Also, that probably is the one with the largest, number of libraries and
libraries
and,
and help, and you can always study those to figure out how to do things. And it turns out that environment has been moved to other processors. In fact, it's been moved to both the one that Ted showed. Show it again, Ted. And the one that David showed. Both of those have variants of the Arduino environment that will work with both of those. That's an ESP, right?
I was showing a Teensy.
Oh, a
I
Teensy?
thought that was a Teensy.
Oh, okay.
Yeah.
I thought it was one of the Wi-Fi chips. So you're probably going to want to get some experience on a microprocessor. Like I say, I think Arduino is the easiest learning curve.
And you'll end up, even if you're using a Raspberry Pi running Linux, you'll probably end up with an auxiliary microprocessor, as Doug was saying, that talks directly to the hardware. The Linux is not really a real-time environment, and there are certain things like handling certain peripherals and so forth. I wanted to back up a little bit, if I could.
Yeah, go ahead.
To fork off what Doug was saying. There's a sort of a handful of disciplines that you need to learn how to do, and play with robots. And basically the first one is you need how to learn how to compile and download code to a processor, to a microprocessor. If you're going to work with the Arduino, that's almost all in C++, or C, whatever you're more comfortable with. We had a member who has now disappeared off into the bowels of Japan, who did everything in, had a whole OS in Python. So that's doable also, depending on what you're comfortable with. But so that's kind of the first stage, is getting that whole development environment set up so you can actually download the hello world of microprocessors is to blink an LED. So you can get to the stage where you can download a piece of software and blink an LED on a little microprocessor. And then the other disciplines kind of arise out of those. You need to learn how to control motor controllers, so you can control motors, and how to read sensors, and then what to do with those sensor readings. There are a number of robots that basically use something like an Arduino or like this STM board or something like that to do all that, and then they send all that to a Raspberry Pi where you have all these analytic and graphing tools and so forth. But that's a pretty big chunk to take right off. My experience in building robots is that what you need right off the bat is some success, and just, you know, being able to turn something on and watch it move is highly motivating. And getting started with a Raspberry Pi and trying to get to that level is a lot harder than starting with a simpler microprocessor. I would also argue that it's not necessary, but you can do it all right here.
Yeah.
$11.
Oh, okay, I can't even see that. What is that? Is that Spark?
This is let me hold it up and you can read the can you read that? Or is that backwards?
New Nucleo 64.
This is an STM, that's ST Micro, and the board itself, you know, that's a kind of a big board, but that's the part, right? That's an ARM chip, and it's just so powerful, so incredibly powerful compared to the stuff we've used over the years, and they're also cheap. Most of your time, you rephrase that. My experience is that the cost of the parts is insignificant compared to how much time you'll put in to use them. You know, people say, how much do you think that robot cost you? And I say, well, the parts are about $500 or $600. And then if I paid myself a quarter an hour, another 20,000.
Yeah. Yeah. But I'm
So
just.
that's
But you don't have to pay
just wanted to
$600 for a robot. That Dave's talking about a really sophisticated robot. I mean, you can get started with if you have $100 to spend, you can get a really nice robot base and a microprocessor. And I have nothing against the ARMs. Nothing against the ARMs. I really like them. In fact, I'm finally working on getting my board like that set up.
I got 2 of them myself.
Yeah.
Getting back to where Ray started, that little kit is an excellent and inexpensive way to get started. You learn how to do the programming, you learn how to do the building, you get the pieces down, you get something moving, and then you move up to the bigger stuff.
Yeah, I didn't mean to be.
Polola sells several kits in various sizes and amount of finish. They sell some completed robots, some you have to do a lot of scratch building with, so it's a good place to start. Polola.
okay. Well, sorry. What kit was that again?
That was the Polola Romy, I think he was showing us. Ray showed us.
Yeah.
Okay. Is that the chat?
ROMI.
ROMI.
Yeah, I didn't mean to be scary with the $600. I was just saying that it can get there when you start buying expensive motors and sensors.
Yeah. You know, for example, you also have to say, well, why do I want to get into this? All right, you should have some sort of feel why you want to get into this, because it is a lot of work and it can be frustrating. But there's 2 reasons why I wanted to get into this. The first reason was I wanted to learn about microcontrollers, because when I started in this, I had no knowledge of microcontrollers. So that was goal number 1 for me. You can get there you can get reasonably good pretty quick. The other side of it that I wanted is I enjoy building robot chassis. I just enjoy doing that. So that's a totally, why do you want to do that? Well, it's just because that's fun to me. All right. I get to use some of my slick tools, you know, and I can have fun with it. But other people have totally different reasons. I mean, you know, why they want what they want to get out of this. You know, I have long range goals, 2 long range goals, and one of them is to have a really good indoor robot that can handle any of our competitions with minimal reconfiguration. I wouldn't say a wooden reconfiguration, but some reconfiguration. And I do want to complete successfully a Romo Columbus, because then I want to go up to Seattle and do a Robo Magellan. So,
well, Doug, I find it very interesting that your goals are based around contests.
well, yeah, that's the reason for that is because those are real sticks in the ground for me to measure my progress. Otherwise, if I can do that, then I know I've reached a certain level. All right.
I guess why I'm not drawn to that myself is that
there's different folks.
The sticks in the ground were put down by somebody else's imagination. You know, what they thought a robot ought to do. And I have my own ideas about what I think a robot should do. And I've used this example before. When I built that 2-wheel balancing robot, there were no competitions for them. Nobody, as a matter of fact, when I got a hold of the people out of Seattle and told them what I was doing, they told me it couldn't be done. It was worse than that. They said they were all a bunch of smart guys, and if it was a good idea, they would have already thought of it.
Yeah. I know.
I'm just saying, I would be careful about letting the contests, which were made up, you know, by guys that are not any smarter than us, to define what your robot ought to do.
Oh, no, I understand that. But what I'm trying to say is they also provide convenient sticks in the ground that if you can do that, then you can say, hey, I've accomplished a certain level. All right. Now, with that lead in, if you guys will pin me, let's see if I can pin myself here.
Well, I think
I'm going to show you
that, for example, the quick trip and the Foursquare are good starting points in terms of getting robots to do something useful.
Yes, and if you look at all, I could put all our contests in a line and tell you how the additional skill you would need to be successful at the next one. So I mean, there's, you know, you start off with quick trip, which just means I can go in a straight line. I don't even have to turn. I just have to be able to go in a straight line and go forward and backwards. And then the next one is 4 corners, where I have to do navigation. But anyway, all right, guys, you see this tantalizing picture I'm showing you? That is a rough draft of probably what?
Doug, it's just a white piece of paper.
Don't move it.
Hold it closer to the camera or something.
Okay, can you see?
Nope, still just a white piece of paper.
Okay, well.
No.
You
Still
can't
make out.
Anyway, this is going to be the 2022 Robo Columbus mug design. So it started.
I thought it was a flux capacitor.
Yeah, well, I'm just saying
I
is
thought it had that shape, yeah.
when I get it a little bit further, along, got some artists helping me. When I get it that done, then I'll post it on the website. So, but again, this year we're gonna have a new mug, new challenge. So I mean, not new challenge, but a new mug to go and get. Yeah. So that's a general competition mug. That's true. Ted, show them your 2022. Do you got it?
Oh, it's in the dishwasher.
Oh, okay. Well, but very few 2022s were handed out.
You mean you actually use it?
Cup gonna have LEDs on it, that, you know.
No.
That's why I build robots. I want one of the mugs.
Yeah. I know what you mean.
Well, I didn't have that strong a motivation when I started building, and part of it was because I was building little Lego things with my sons when they were young, and we'd build these little cars and so forth, and they'd just run into the wall, so we were trying to what can we do to keep it from just running into the wall? But the real reason is because ever since I was that age, I always thought robots were cool.
Yeah.
I just thought
Yeah.
they're cool. I'd like to do something cool. And so my goals, rather than to win contests, is basically to have something I can sit back and go, oh, that's cool.
Oh, yeah.
It's
Well, that's the way I feel about my claw
Motivation
machine.
right there.
Yeah.
I built the claw machine just for that Halloween carnival, and I'm gonna build another one this year, a different one. So the kids love it. I think it's cool.
Yeah.
Yeah, I got into robots. I'm a machinist by trade, and I work in maintenance. I'm a maintenance machinist, or was. I'm retired now, but they were forcing me out of my position, and this happened everywhere. They wanted me to learn electrical and go out there and do Mr. Multitasker out there on the production floor. So I started taking an electrical course, and I started researching PLCs. I started researching PLCs. And I ran across an Arduino while I was researching PLCs because I wanted to understand how PLCs work because I'm in that environment. And I forgot all about PLCs and started peddling with an Arduino. And then I ran across you guys on the internet, and I started building robots because I like to make stuff. I just like to make stuff. I'm more of on the all of my robots that y'all ever seen me at the club back years ago was most of them I made myself with my 3D printers and stuff. So I just like to design and make stuff. So a lot of that motivates me to keep going.
Mm-hmm.
So.
Mm-hmm.
So anyway, it's funny how I wasn't even looking for a robot. I was just trying to research PLCs and ran across Arduino on YouTube.
And you got sucked in.
And I got sucked in. Now I'm an addict. Talk about how much money you spend. When you're addicted, you don't care. How much money
Yeah,
So,
and you can never have just one.
That's right. Man can't have too many robots.
So anyway, that's the story. Also, my background also is I used to program PLCs for a living. So
Yeah.
I've kind of got some programming background too. G code stuff.
Yeah.
I used to program CNC mills back when we had to do it by hand because we couldn't afford Mastercam.
I think those were called numerical control. I don't even think they were called CNC.
You made a decimal mistake, it was a lot of fun cleaning all that up. But anyway, so.
Well, Doug, I don't know if this would be of any use to Benjamin. Benjamin, are you still with us?
Yeah, I'm still. Actually, I have a thought here. Should I start with at least understanding microcontrollers first? Is a basic step towards robotics.
I would say that would not be a mistake. Okay, if you want to, if you just now, like I say, if you really want to build robotics, then I would say go ahead and pick up a kit because you'll learn. It's a good way to learn about microcontrollers. Otherwise, when you get your kit together, they'll give you some sort of demo program. But that's it, Jack. You got to program it. But you having a good example and probably an API, which was the word I was trying to think of, an API that can get you started in some, learning how to do programming a typical microprocessor.
Benjamin, did you see the books that they were just holding up?
The books? No, I did not.
Yeah, Michael and Ray are both holding up books.
Yeah.
Okay, Adrena code book. Yeah, a lot of
What's
These
with
are
all this
good
microprocessor hooey? You just need to throw some transistors together and you're good.
Well,
There
as a
you
matter of
go.
fact,
555 timers.
as a matter of fact, can I
You guys-
take over here?
Could you guys write that down in the chat? Is that too much to ask?
Sure.
Thanks.
I think you're. Yeah.
If I can present. Little screen. This is always so confusing.
Come on, you're a cyber security guy. You know how to take a screenshot.
You know, I was caught up in the moment.
Are you guys seeing a picture with some of my robots?
Yeah.
Yes.
Okay, this is my first robot. What does it say, 93? All Legos and transistors and a couple of relays. I actually have a video here of it doing something. But that was part of the, just get something running, just get something working. And these were what I built with my kids. Also, we put a TV camera on and built a remotely piloted vehicle we could drive around the neighborhood, which was a lot of fun. That grew into this much more sophisticated, but still Lego robot, which then turned into this one, which doesn't use Legos anymore, and eventually into this this one here. I should get a better picture. And the two-wheel bouncer I mentioned earlier, and then this is a fairly large, about 25-pound robot. This is the expensive one that has a lot of expensive parts. So you can see there's kind of a progression here, just like Doug was describing.
So David, what sensors did you have on that first robot you built?
Just the front bumper.
Okay.
And when you hit the front bumper, it started charging a capacitor, which then forced it to back up for a certain period of time until the capacitor tripped and dumped, and then it went forward again. And you could do that either while rotating left or rotating right. But it was enough that we could then put it down on the floor and it would run around and not get stuck, or not get stuck as much.
Yes.
Yeah, many moons ago, I took a Lego and put a bumper like you had on it, and the two switches on the right and the left, and programmed it, and it ran around and bumped into stuff, and I saw it got trapped, and so I put a random number generator in there as to how long it should back up and turn.
Well, as a matter of fact, let me now that you mention it, boy, it's raining so loud here I can hardly hear.
I can hear it.
If you look, let's see this little board here on the back? That little board looks for since it's just a bump and run algorithm, you hit something on the right, you back up and turn left. If you hit something on the left, you back up and turn right. That means you can get stuck in a corner where it's just bouncing back and forth. So this thing here is counting the number of times you bounce back and forth before this capacitor discharges, and it triggers basically a 180-degree turn. So it could get unstuck from the corners. We were very proud of that.
The other thing you run into is, like I say, it's a deep hole. Otherwise, the more you learn, the more you learn the subtleties of things, and I'm sure David could mention this. He learns something, even though he's got some robots from way back, he still learns something every time he runs his robot. And he's always constantly improving it. And
there's nothing more useful than just sitting there and watching the robot run for a long period of time and see it get in trouble and just leave it there and think, all right, how can it know that it's in trouble, and what could it do to get out? Mm-hmm. How could it get loose from this situation? Yeah. And yes, and that's what makes me think that self-driving cars are a long way away.
Well, Hey,
just an
Kareem.
experiment at this point.
Yeah. Hey, Kareem, are you there? I don't know if this might be too elementary for you, but I mentioned at the beginning of this meeting that the link that Pat put in for that video on YouTube about how basically is how to make a more robust data set and data set mistakes that you can make was really good. Really good, I thought. I mean, it pointed out some things that I know I've done in the past, so maybe, like I say, it might be all old hat to you. But Did you?
it pointed out plenty of things that are wrong with the stuff that my kids have done,
Yeah.
and myself as well. So
Yeah.
yeah, we make all of those mistakes.
Yeah. Well. So.
By the way, I picked up
Michael.
I picked up the
Smurf.
Smurf
Okay.
doll.
Okay. And now after.
And I reread the rules, and I realized that our robot's not going to be able to compete.
No, don't give me that. You're going to compete. We will make the rules so you can compete. What is it? Home base too small?
Right now, you have a robot that has to stay within 18 inches all the time, and
18
that's like our
inches?
starting.
What?
That's our starting size.
Well, that's fine. We'll make a 24-inch box for you. Yeah, that's not a. I'm more interested in somebody doing showing an example of deep learning. That's what I really would like to see us get there at that thing. But you know, after looking at that tape, that YouTube video, you know, I'm glad you got the doll. But you know, it sounds to me like what would be useful is just to grab 1,000 images off of YouTube of Smurf dolls, you know, and
Yep, you can do that.
and just go ahead and start, you know, annotating them. Anyway, I just thought kind of interesting. Okay, great.
Annotating is the most boring thing
Yeah, I know.
that there is.
I know.
But, yeah.
And you would think that somebody would, you know, you think somebody would figure out a way to like use a partial model. Otherwise, the more you did, you know, the more it would kind of take over. So that eventually, when you got
They do have
finished,
that.
you would just be reviewing to make sure you didn't make any mistakes. So, but anyway,
It's the cart and the horse problem, because you gotta have a starter training set anyhow in order to recognize it in the first place,
yeah,
classify it properly. So,
yeah.
but there are iterative approaches.
Okay, so
How do I present?
I'm sorry, Michael.
How do I present?
Uh,
Can I
the
present something?
yeah, the box with the arrow that goes up down at the bottom.
Right
Yes.
next to the hand.
So
Yeah.
will it present whatever's on the screen?
Yeah, if you do full screen.
Okay. I'm gonna present and show you. Actually, my first robot. Is he still here? Who was it? Benjamin?
Yeah,
Yeah, I'm still here.
Yeah. Let me just show him that. Okay, entire screen.
you got to click in the box.
Well, let's see. Do I want to do it?
You have to click.
There we go. Okay. Y'all see that? There we go. Check this out, guys. This is 2016. Can y'all see that?
Yep.
Yep.
And there's Will sitting there.
That's huh? Yeah. That's a line first robot for the competition. And I won first place. You know why?
Why?
Nobody else entered it.
Well, that's okay.
Nobody else entered the competition.
But you made it all the way around too, so
Anyway,
that's good.
I made it. That was pretty good.
Yeah.
And not a lot of wiggling or nothing on that one.
Hmm.
So, and the reason why I'm showing you that is because I accidentally ran across this video on Facebook the other day.
Yeah.
That looks like
Anyway,
me.
there we go. Yeah, no, we got a lot alike. How do I? Okay, now just
The same beard.
not presenting. Yeah.
Also, whoever that young lady was in the foreground with the red hair has a dead ringer for a cone.
It's a red hair.
Yeah, somebody in the foreground there had red hair.
Oh, that's my granddaughter.
She should stay away from the can collecting contest.
That's my granddaughter, right? That's why I did line following.
Yeah. But there, Ben, there's another thing. if you bounce around on the DPRG website, dprg.org.
I'm searching it right now. Okay.
Okay, there's a bunch of stuff there. Let's see. There's history of the club. If you go through all of that, and you can see there's video. There's a big YouTube collection. If you want to see what things look like, say 5 years ago, you can go back 5 years in time and look at some of the videos. The website has a lot of these meetings posted on it, but if you look through the news archive, you'll also find presentations that were made by different speakers, and also probably some of the things about the competitions. And one of the things I wanted to mention is, if you go to, I think it's the competition tab, you'll see the next two tabs, and you'll see the contests that are being run. And you can also look at the rules sets, which is on another little sub tab, and you can actually look up the rules. And like I say, there's kind of a progression of things. You know, one of them is line following. It's in that progression, so you can look at what we try to do is match the contest to where the club is at the moment. Okay, so that there's always something a little bit challenging for people, but also somewhat familiar, because a lot of times when you first try to run one of these contests, you don't do very good, and so you want to be able, you don't want to be that's the last time you ever have a chance to run it because you missed it. So you know, it comes up periodically. So anyway, you can look through that website. You should be able to find some stuff. Okay, and
Gotcha.
Doug, I found a video of a can I can show.
okay.
Was that a nodding head? Ray's nodding his head. Do you have a video on screen?
Yeah.
Yes.
Okay. This is from, I don't have a date on it. In this competition, basically the judges, there's this big T-shaped course, and the judges laid out 6 cans. Actually, sometimes they just had a kid go, and you have to collect these 6 cans and bring them back behind the starting line. So this robot's using a sonar to identify the cans, and then it's got a little gripper under the front bumper. There, it grabbed one, and then it uses odometry to try to find its way. And it actually tries to offset the cans from each other so you can see how much the odometry has drifted. We don't use this big competition course anymore, which is too bad. The one we use now is just a rectangle.
Yeah.
And there's a real advantage to having this. You have inside and outside corners in the T course. But the reason we came up with the T course was because that was the shape of the space we had when we were downtown. Yeah. And so it just kind of stuck.
This was the science place, right? The old science place?
Yeah, but this was in the science place. That's right. But at that time we were meeting at the Info Mart.
Oh.
And
Okay.
this was the shape of the space inside the Info Mart. So that kind of became our default. Okay, well, it's actually pretty boring when it works, so that's enough.
Yeah. I'm going to say that we do have a course that we haven't used in a long time, Dave. That's been, it's not that one because it's not that tall. I don't know where it came from. I don't know what shape it is. I just know it was very well built. So we didn't throw it out. And it might be a T-shaped course if we wanted to do that. I don't know. I'd have to look at it.
Well, there's advantage when you do things like wall following and so forth to have both inside and outside corners to have to deal with. And also to not be able to see all the cans from the starting position.
Yeah.
You know, there's cans over there in the teeth.
Mm-hmm. Yeah, well, usually the robot can't see all the cans at once because they don't have a good enough field of view. We try to put them so that there's not you have to go after one of them at least. But you know,
that video is probably 15 years old. Pretty much everybody now, the cans are all orange, and everybody uses cameras to locate them now.
But that's going to change because Kareem's going to show us the way. So in the future,
well, it's still camera.
Yeah, it's still camera, but they don't have to be all orange. They just have to be.
Now,
you know what I mean?
Let me point out that the way I was finding them with sonar was indifferent to their color.
Yeah.
And when I showed up at the first contest and saw they painted the cans all white, I cried foul. Those aren't Coke cans.
Anyway.
Didn't exactly impact your ability to find them, though, did it?
No, that's what I'm saying. For the sonar, it doesn't make any difference because it's looking for basically two edges that are about the right distance apart.
Yeah.
Mm-hmm.
Were the walls white as well?
Yeah.
They weren't white.
Yeah,
I think they were orange. I think we went orange right from the beginning. I don't think
for the cans. Or?
Yeah. Did you see white cans?
That's what I just showed.
Those cans were white? Oh.
Yeah.
Yeah, they were.
Okay, I didn't know that.
That was before you were in the club.
Yeah.
It's back before we had color vision.
That explains it.
Yeah. But anybody else got anything else to say?
I've made some progress in the platform back there. I've got the wheels turning. It's up on a box.
Okay, let's see it.
Well, I actually have to hook up my other laptop because it's I'm using one of the RoboClaws and just driving it. I realize one side is backwards, so I've got to switch wires around. So that's about where I'm at. Just found a pretty good way to mount the mast. Actually used some hardware from IKEA. IKEA used to have this array of bins that you could go and pick up, individual pieces that you lost. And so every time I go to IKEA, I'd pick up, something that looked interesting. So I finally got to use some of them. It's like a kind of like a bar that has a a threaded hole in it, and you use another fastener to snug it up. It's used to hold furniture pieces together.
Yeah.
But that's what's holding fast to the base. So I've got the B&O 055 on the top with a little OLED display so I can tell what it's doing. And it's got an ESP32 the ones with LoRa, long range radio, and that also has a little display on it, but once it's in box, you can't see that well, so that's why I put one up on the mast on top. But that's the other extreme where they're doing something completely custom, but that is a good example of time dilation, where time just seems to slow, your progress seems to slow down because you're making every single little part of the thing.
What's the processor? I'm sorry, Ray. What's the processor you're using there? I missed that.
Oh, it's an ESP32, and it has a LoRa chip on it and an OLED display. It's they're a little pricey. I think they started out less expensive, but no, they're getting up to like $16-17 a little board.
Well, did you guys, I don't know if I remember to post the link, but I ran across a Philips light bulbs that have an ESP32 built into them. Have you guys seen these?
The U? Is it that one?
No.
They're like $15 at Home Depot.
Yeah.
And you can talk to them with Bluetooth. And,
So you can control the
yeah,
Wi-Fi?
you can talk to them with Bluetooth and
Oh, Bluetooth, yeah.
or Wi-Fi, and turn the lights on and off, and it's actually pretty cool.
Yeah, yeah.
But I was not struck that this is an expensive light bulb. I thought, my God, how did they afford to put a microprocessor in it?
Yeah. I mean, ESP32s are cheap, but Anyway, so that's like a skid steer. Bolt. That's the wheels on one side are tied together with chain drive. I suppose I could pick it up and show you.
Well, in terms of cost, the Micro Center has the ESP32 camera, 2 to a pack for $17.
Yep. Yeah, that's a pretty good deal. Anyway, these were worm and worm gear motors that I got from Service Center, and cheap brackets to hold the motors and to bearings, and then the brackets tie left side and the right side together. So you probably can't see that moving, but
Hey Ben, if you pin his picture, it'll get bigger for you. I don't know if you're familiar with how this works.
Okay, yeah, thank you for that tip there. I can't see it though.
It's in the middle of the. Go to his picture, and in the middle there'll be a pin, a microphone, and I don't know what the third one is.
Yeah, it
The
makes
only
it
problem is,
I think the problem is his feed. His feed is low resolution.
No, I was talking about the picture quality, not so much the pin.
yeah, it's a little fuzzy. I'm out in the country. I have to use smoke signals.
yeah, I think it's the
For
same
making it.
resolution big as it is small.
Anyway,
Ray, how much do you
Anyway.
think that weighs at this point?
too much. Maybe 15 pounds. It's got a half-inch
It's a luggable.
plastic base.
And that's without batteries?
Yeah, I just have I'm going to use like a 14.4. I don't know, maybe it weighs a pound, but those. I think that one's 4,500, 4.5 amp hour capacity. So
How many, is that 6 cells? Is that a 6S
14.8.
battery?
that's 2, 3. I think it's actually 4 cells. Isn't it? Whatever multiple of
He said
3.7
14 volts.
gets you up
so
to
it's
14.
4 cells.
4 cells. Yeah. Anyway, that's, like I said, the opposite of what you want to do when you start out.
Well, 4
Everything's
cells,
handmade.
you can hardly catch anything on fire with that.
Those little motors are pretty fast. It's got 10-inch wheels, so everything's ball bearing, so it's fairly low friction. So I'm hoping, I was going to call it, well, basically I just wanted a robot that would beat out what's his name, and now I can't think of his name. Scott, yeah. So I was gonna, the Scott's Robot Killer is what I was gonna call it, So don't know if I'll ever be able to actually make that claim, but I can only name the robot that. But,
Very loud in here when it rains.
Anyway,
He was acting very loud.
what's that?
So the answer to the question, what does it sound
Oh,
like
it's
at
raining.
Michael's new shed when it rains? And he says it's very loud. He had to put his headphones on.
He's raining like crazy right now. So.
I tell you, if it starts thundering, you better get out of that thing, because metal shed, boy,
I don't
It's
know,
grounded.
but wouldn't you be
It's
safe?
grounded.
Wouldn't you be safe inside of it?
Yeah, it's
We'll
like
find
being
out.
in a Faraday cage.
I got struck by lightning in a truck, and I was safe inside.
I bet
Oh,
that
you
was,
were? Yeah.
how loud was it though? When you got struck?
How loud? I didn't hear a thing. Everything went white. My view out the windows went white for a split second. And I was driving down the road at about 30 miles an hour, and so the windshield went white, all the windows went white, and then back to see-through. And when I looked behind me, there was a branch from the tree I was driving under that had exploded.
Yeah, I mean, you can get, lightning is what, millions of volts. I mean, it can hit a tree and still have enough potential to shock you if you're touching that tree, standing on the ground or something. So, it could still be several hundred
Okay.
volts or something.
All right.
Well,
Hey,
Michael, it got so loud in here I couldn't hear anybody a while ago.
Oh,
That's why I put my earphones on, because I couldn't hear.
Okay, Ben, I don't know if this has helped you at all. I hope it's given you some food for thought. I hope you'll come back. These meetings are usually a little bit bigger than this, and we
And a
usually,
lot more interesting.
yeah, a lot more interesting. Usually we have something to show. I came very close to having a demo tonight, but I guess I should be happy because I found a problem. The problem
I
was,
do have two quick questions.
yeah, go ahead.
Spark Fun and Honolulu. These are places I could get robotic kits to get
Should
started.
be able to, yes.
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 Okay, cool.
There's another place that you should know about, because they do have a lot of stuff, is Adafruit. See if I can spend.
I would add
Yeah,
Ada
he could just
and RoboShop,
Yeah.
Robot Shop.
he could do just a search on Amazon for Arduino kit.
These are two places that just got mentioned that are top-notch sites for stuff. Yeah.
Yeah, those are all good companies though that have been mentioned so far.
Yeah.
Doug, what's the name of that place that has all the nifty, alt azimuth tables and little ways to hook servos together? And you know what I'm talking about?
Yeah, I
can't
know
remember
what
the
you're
name of it.
talking about. Kareem probably is more familiar with that.
Go Builda.
No, it's
No, it's not.
Micro Daughters. No, that's
Servo
not it.
City?
No.
Servo City.
Servo City.
Servo City.
Servo City.
Servo.
Yeah.
We get a cut, of course, of each one of these every year.
I wish. We do, I'm not sure, if you look back through some previous posts, there is a 10% discount at SparkFun for if you order what they call their X series. And those are essentially boards that they're still trying to determine if they're a product or not. They're usually very leading edge, but something that's worth knowing about. I can't give you the code because I don't know it, but if you look back in a couple of meetings ago, I'm sure you might find it. Oh, I know where you'd find it. If you look at the talk on, what was the name of that, Ted, what was the name of that contest? The one that Jesse was in?
Oh yeah, the Oak D-Light contest.
Yeah, but so yeah, if you look at the Oak D Light, if you use that as a search term, you'll probably see Jesse's presentation show up. And in his presentation, he did give a code out. He's one of his functions is as a Spark Fund representative or ambassador. All right, guys. If it doesn't seems like anybody's got any robot stuff to talk to, and
No, I have a very important question.
okay.
I want to know, Dave Ackley, who are you kissing over there?
I think that's his daughter.
Come on, fess up, Dave.
No, that's my mistress. No. No. No, that's my daughter. But that does remind me of a Shaggy Dog story that I told. One time I was at one of these country and western places with my wife and her girlfriend, and a fellow came up to the table and said, you know, he wanted to dance with one of them, and he said, you know, who's with who? And I said, well, that's my wife and that's my mistress. Why? He went,
Hey, Doug,
We're just
can I put that discount code in the chat?
Oh, did you? Thanks.
Can I?
Oh yeah. Well,
Yeah.
Yeah, I think so. It's good till the end of the year, right?
Yep. That was Spark Fun, correct?
Yeah. It's not on all
Maybe
Spark.
next week I'll have a video of.
Yeah, it's not
that
on
thing
all
crawling
Spark
around.
Fun devices. It's only on their, I believe they call it the X line or X series.
It's their
Oh, it is?
original,
It's
the
using
ones
everything.
that they
It's the
designed.
one that they design. Yeah.
Yeah. Spark Fun Originals.
Spark Fun Originals. Yeah.
You said this meeting was recorded and it's going to be posted on the dp.org.
Yes. If you go out there and look at the website and you go under news, you'll see all of the past meetings. And that's a good, if you want to see if this is something that you want to keep coming to, you can go down there and look at what's been done in the past and see, you know, what you're going to find is there's pieces of gold in the pile of awful. So you have to just,
You just have to be a treasure hunter.
In the
Yeah.
pile of endless kid conversation.
yeah. Okay.
And like, what's the plan to have in-person meetings anytime soon, or is this for the time being going to be virtual meetings?
Probably the next one that we're going to have is the competition in June. Okay, so that is going to be, you know, in the Dallas Makerspace on June 11 on Saturday. It'll be the competition starts at, I think, after pizza at noon. So we have a setup in the morning. There'll be pizza at noon. There'll be contest, I think, actually starts at 12:45 if I remember right, maybe 1 o'clock, and then they'll probably go to about 3. It's gonna be a good time to meet people in person too.
Yeah, I have a lot of burning questions.
Okay.
It's a bit overwhelming being a new member, you know,
Yeah,
with
yeah.
these type of things, you know.
Yeah, I know it's tough, and I'm sure we haven't made it easy because, you know, we kind of talk in generalities right now. But I think as you start to dig into it, I think like I say, I guess my first thought would be to go ahead and get one of those Arduino kits to start with. That'd probably be a good way to get you into the microprocessor. If you have a choice between an Arduino Mega and an Arduino Uno, go ahead and get the Mega. it's more flexible.
Hey, no,
My recommendation would be the Pololu Romy.
Yeah.
Not very expensive. Has everything you need to get you going.
Lulu, who else?
It's in the chat.
Is the chat gonna be saved with the website posting for this?
Yes. I try to save all of them.
Cool.
Yeah, I listed random nerd tutorials. So he has great series, you know, and some of his, you know, you can download some of his stuff for free. Stuff also is reasonably priced. I mean, you know,
Well, I
$20
do.
for
Mhm. Yeah, I like
some of
I
the books.
think
and stuff,
I
so.
like the computer vision zone. That's another good one, I think.
Mhm.
And
Yep.
I just got computer vision zone ran a contest where they wanted everybody to go at least see one session of the NVIDIA conference that was on, big conference with, professional conference. And I entered that contest and did watch a couple of sessions, and I won a $90 gift certificate to take a course, an NVIDIA course, and I just signed up today. So I'm curious of,
Cool.
yeah, I mean, it's, me, if it was $90, I was probably not going to do it. So we'll see how this goes. I'll tell you if it's worth it. It's an 8-hour course. We'll see. So.
Mm. Good deal.
Yeah. Okay. All right then. Well, I'm going to say, if nobody has anything else to add, I'm going to stop the recording, and we can either drop off or oh gosh, I can't find it. I hope the recording has been going. And looks like it locked up.
Party on, dudes.
Okay. All right. We'll see you guys. Bye-bye.